Okay, we're trying to find the true inclination of the surface A. So what you're looking for here is the true inclination of an oblique plane. True inclination is a fancy term for the true angle of the plane. We've got a plane A there. I'm going to label it A, B and C in plan. Point C is here, point A is here, point B is up top. We want to find the true angle of it. To find the true angle, we look at an auxiliary view. We want to look at what's called the edge view. To find the edge view, we have to look along a horizontal line. They've given us a horizontal line in elevation here. They've called it 1, 2. So what we're going to draw is an auxiliary elevation looking along line 1, 2. To do that, first up, I need to find that line in plan. So 1, 2 in plan, first off. Bring down point 1, and it's on line, don't mess this up, it's on line BA. So 1 is on line BA, down with it. Point 1. 2 is on line BC. 2 is on BC. We find line 1, 2. Now, we didn't actually need to do that, but the worksheet has asked us to do that. If you look at it, AC was already a horizontal line. So I could have just used AC as the horizontal line. But it doesn't matter because you can see 1, 2 and AC are parallel to each other. It's the same thing. So if I look along 1, 2, it's the same as looking along AC. We want to draw an auxiliary elevation. Auxiliary elevation, always drawn from plan. So we're looking from the plan. I'm going to look along line 1, 2. I'm going to project out along 1, 2. Again, that's the same as looking along line AC. So I project out looking along line 1, 2. Set up my XY line anywhere up here. I'll set it up here someplace. That's my X1, Y1. So I'm going to draw an auxiliary elevation up here. Project my 3 points into elevation. So I've got A and C are going to end up on the same line. B is going to end up on top. I'm drawing an elevation, meaning I'm going to measure my heights from my elevation. So in other words, the height of B that I need to measure is here from elevation. So height in elevation is always the same, whether you've got an elevation or if you've got a front elevation, end elevation or auxiliary elevation, heights are the same. Height of B, I take the height of B on the compass. Follow up point B and we get point B in elevation. I find the height of A, which is 0, it's on the XY line. I project up A, here is A. I project up C, the height is 0 on the XY line. So I project up C, its height is 0. So A and C end up in the same place. Here is line 1, 2. Here is the edge view of ABC. Line 1, 2, when I project it up, line 1, 2 is here. That is the point view of line 1, 2. I could have alternatively got 1. Here I project up point 1, and you can see I take the height, it's in the same place. So it's the same setup. 2 is the same thing. Here's the height of point 2. Project up point 2. Again, it's in the same place. And we've got an edge view of the plane. So that triangular plane now looks like a line. We've got A, B and C, and we've got an actual line drawn on it. So to begin with, we had a triangular plane with a line on it. Now we have an edge view of that plane and a point view of the line. The line looks like a point. That's important. Second question is exactly the same. Determine the inclination of the laminate to the horizontal plane. So in other words, I'm going to be drawing an auxiliary elevation. Again, I label the points. Doesn't matter, I'll call it A, B and C. And it doesn't matter whether we label the points in elevation or plan. Here's A in plan, B in plan, C in plan. So A, B, C in plan. Now, again, to draw my auxiliary elevation, if I want to see an edge view, it has to be along a horizontal line. So I can go up here someplace and draw a horizontal line, but I don't need to because I see in the question AB is already a horizontal line. So AB is horizontal in elevation, so it's a horizontal line. So I could draw my auxiliary elevation looking along AB. So again, the rules apply. I've got my horizontal line AB. I'm going projecting an auxiliary elevation. Elevations always have to be drawn from plan. So I'm coming down to my plan. I want to look along that horizontal line. Here's the horizontal line in plan. It's line AB. I'm going to set up my XY line. XY line is at 90 degrees to the line of sight. So I'm projected out along AB. I'm going to set up my XY line at 90 degrees to that. Anywhere there with the XY line, I'll call it X1, Y1. It's an elevation I'm drawing. That line represents the horizontal plane. Just like up here, here's my elevation, here's my XY line. Elevation, my XY line represents the horizontal plane. This is an auxiliary elevation. The XY line still represents the horizontal plane. I'm drawing an elevation. I'm going to take my heights from the elevation. So, my heights for A and B, I've already projected out my line. I can take height for B and A are the same. A and B are projected out along the same line, so when I come to do it, I get my height for A and B. A and B are both there. Point view of the line AB. I project out line C. And again, I need to find the height of it. So, height of C is here in my elevation, and I'm going to strike it off in the plan view. And it comes right to the bottom of the page. So again, off my XY line, get point C. Again, my edge view. So that is an edge view of the plane, and what we were looking for was the true inclination of the plane. The angle is between the plane and the XY line. So my true inclination is here. And I can measure it with the compass, or sorry, I can measure it with a protractor, or just write down the inclination. And it's the true, so that's the real angle it makes with the ground. So the rules apply. If you're going to find the true inclination of a plane, look along a horizontal line. Draw an auxiliary elevation which looks along a horizontal line.